Alright, welcome. This is the 7.2 Ready, Set, Go homework solutions. Alright, you have the first one. It says for each set of lines using the point on the line to determine which line is the image and which line is the pre-image. Write the image by the image line and the pre-image by the original line. Then define the transformation that was used to create the image. Finally, find the equation for each line. Okay? We can tell which is the pre-image and the image based on the notation. The new image, okay, will always have the prime. The pre-image will never have a prime. Okay? So, the bottom line here, I'm going to call this the pre-image because it's A and B. Up here, it has A prime and B prime. That prime is that like hash that is on the top right hand corner. Because it's there, you're going to call that the image. Here, this is the description of the transformation. It goes from here to here. So how do you go from point B to B prime? It seems like it only went up 1, 2, 3, 4. That's why the translation, it is y plus 4. This is the general rule. Here, you could grab the equations. Okay. The slope here, 1, 2, 3, 4, and across 1, 2, 3. So both equations will have the same slope of 4 over 3. But the y-intercepts are different. The original one is -5 because it goes from -1, -2, -3, -4, -5. Okay, the pre-image equation is y equals 4/3 x minus 5. You apply the translation of plus 4 to the y. That's why the new one will have the y-intercept at -1. So its equation would be y equals 4/3 x minus 4. Next, again, same rule. The pre-image just has the letter, and the new image has the prime letters. So the equation that has that negative slope down here would be your pre-image, and the one that has a positive slope, which is going that way, would be your image. Okay, this would be a reflection over the y-axis, over the x-axis, I mean, right? So the pre-image is y equals -3 over 2x plus 1. Right? It goes down 1, 2, 3 across 2, 1, 2. That's how you got that slope, -3 over 2. It went down 3, went to the right 2. The image had the slope 1, 2, 3 across 2, 1, 2. Notice here that the slope just changes signs. When you reflect over the y-axis, in this case, okay, the slope changes. That would make sense. Okay? Good? Does that make sense or no? Remember, this is a change of y. Okay. Alright, this is here. Let me just write this out for you. This is a change of y, and this is a change of x. Because some of you are wondering why that occurs. Okay, I can tell. Alright, notice the fact that you reflected over the y, the change of y changes signs. Good? It no longer goes down 3, it goes up 3. Okay? But nothing happened to the y-intercept. Good? Alright, let's look at number 3. This is the image, and this is the pre-image. Its original is GH, and the new image is G prime and H prime. What happened here? It looked like it translated 7 to the left. Let's see if we are right. You go from G to G prime. Let's count. 1, 2, 3, 4, 5, 6, 7. Yes, it did go 7 to the left. So that's why it is the translation, x minus 7. So, the pre-image. The pre-image here, right, cuts a little bit here. So, it would have y equals -1/3 x plus 7/3, right? That because of the y-intercept here. But the slope should still be the same, -1 over 3. Goes down 3, across to the right down 1, across to the right 3. Down 1, across to the right 3. 1, 2, 3. Same thing for the equation for the image. Okay, down 1, goes to the right 3. 1, 2, 3. The y-intercept here is 0. 4. Here's the pre-image. The pre-image, M and P. The new image, P prime and M prime. Okay, what happened here was a 90-degree rotation above the origin. The pre-image is y equals -1/2 x minus 5, and the new image is y equals 2x plus 0, or you can just write it as 2x. Either way works. Okay? Alright, next one. Construct a parallelogram given the sides x, y, and... Okay. Alright, so this was your XY right here, and it was XYZ. I don't have the letters here, but in your workbook, right, you should have it. Okay, I'm going to construct a parallelogram. Alright, very straightforward. You're just going to use circles, right? We've been doing that all the time. So, oh, that's not even a circle. Let's make a very good circle. Let's try to make a good circle, okay? Circles are symmetrical. Alright, the fill here would be no fill. Alright, let's see. Is that a good circle? Now a little bit more. Good. Nope, a little bit wider. Yep, that looks like a very good circle. Alright, so this has the radius right here. This is going to be its radius of that circle. Okay? Alright, so from here, we can also get another one. Does it want to be, yeah. So this, I'm going to make this red so we could construct its circle. And it's a smaller radius, so it's going to be a smaller circle. Okay. Here you go. No fill. And the line here is going to be red. A little bit bigger. Perfect. Alright, so from here we can construct a couple of things. Okay. From that intersection here. Okay. From this intersection, from the green radius, from the blue radius, we construct another side of the parallelogram with that radius. Okay, there you go. So this red circle has this red radius. Same circle from here. That's why it's both red. So it has to have the same radius. Good? And we'll have our blue circle, our big one. I'm going to place that right. Hold on. Right. Right. Where? Hold on. Give me a second. Give it right there. No. Whoa. 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 Oh, give me a second. Hold on. It goes down there, so I need a line down right there. So, boom. Okay. There you go. So that would be your second circle. Whoop, sorry, that's a little placed off. Okay. There you go. So, your second circle, the bigger one, is that line length, that radius from the big circle, blue one here. That radius is going to give me the top line for that parallelogram. Okay. So let me just delete all the circles so for you can see the parallelogram neatly. There you go. That's your parallelogram. Okay. It's constructed from these circles. Good. And they're constructed from the radiuses of those circles. Alright. Construct a line parallel to QT. This was QT right here. Alright. QT. Good. Alright. So the first thing that we can do is we can construct a line from here to this point. How do we do that? We just draw a line using our straight edge from this point past this point. Okay. Next, we can grab our circle if we want a circle. Okay. Just to define this, give me a second here. There you go. No fill. Good. Alright. So, notice how I'm going to try to make this its radius of the circle. So let me just try to, yeah, that looks good. So this line, so this blue line, this blue circle, oops, sorry, this blue circle, I'm going to make it, yeah, baby blue. This blue circle has this radius. Alright. blue line, and that's gonna be weight. Good. Has that blue. Good. Okay. So this blue line segment right here of QT is this radius of this blue circle. Okay. From here, what you can do is you can grab this same circle, okay, and extend it from this point. So, boom, circle, boom, here. Right, making this dot its center, making this dot its center. Okay, here are my words. Making this dot, right, hopefully I could make this dot right there. This dot here, making this dot green. Okay, hopefully you could see it. Right, its center. You could draw its radius. Okay, because this and this are the same lengths. Notice, right, same length. Okay, its radius has to be the same. Okay, it's off a little bit, but you get the idea. Good? Do you see that? Because, right, I constructed this green circle from this blue circle, right? It has the same radius and it has the same radius. Good? Okay, let me repeat that in another word to make it a little bit clear. This blue circle has this blue radius. The fact that I constructed the same size circle, the same circumference, the radius has to be the same. So the blue circle has the radius blue. The green circle is the same as the blue circle, so it has to have the same radius. Good. And it is separated by this line here from that point. That's how you construct parallel lines. Okay? Let me just delete it for you. There you go. Those are your two parallel lines constructed from these two circles. Good? Alright. Sorry if that's a little bit wordy, but hopefully you get that. Okay. Next, construct, given a segment AB here, and point C such that A and B is an isosceles triangle. Okay. An isosceles triangle. An isosceles triangle is a triangle that has two equal sides. Yeah. Okay. It's easy when we make an equilateral, but yeah, this is going to be a little bit harder. So first of all, I'm going to construct. Whoop, that is not a good circle. Okay. No fill. Okay. First of all, I'm going to construct two circles so that its lines here are the radiuses of the circle. So that is going to be weight. There you go. So I constructed the left portion of this line segment is going to be the radius of this blue circle. Okay. Boom. Then I'm going to construct another circle that's going to take up the right hand side, and I'm going to call this the red one. The right hand portion is going to have the right radius. Okay. The fact that it intersects here, right, and I split it, there's a bisector, so therefore I can draw a line straight down. Okay. Let's make that black. Make this 2.5. Good. Right. Here, I could draw a couple more radiuses. Boom. From here, extend the radius up. Right, the red radius as well. Right, same center. Extend the radius up. Okay. Notice that it doesn't really reach, so I would have to extend the radius a little bit more. Okay. So I can make this circle bigger. Right. I think I could go to size here and just double it. Oh, let me lock. Let's just do it 200. Please don't over. Yeah. Okay. It still has to be the same center. Alright. And this line, right? Because I made that 200 bigger, this also has to be 200 bigger. Whoa. Yeah, you see? Boom. Sort of, sort of. It's a little bit off. I know. Sorry. It's a little bit off. Okay. Same thing here. But I have to make this red one a little bit bigger, so I'm just gonna change that to 200. See how he got bigger? Alright. Okay. That means this line segment is going to be bigger by 200 as well. Yes, I understand it's a little bit off, right? Okay, I don't have a machine doing this. Okay, but you sort of get the idea, right? Sorry. Okay, it's supposed to be a good equilateral triangle. All right, a little bit off because it's not on a grid and it's not a computer. I'm just doing this on Microsoft Word. Give me a break. But here you go. This is your construction of your equilateral triangle. Okay. All right. You start with your two small circles. Okay? You start with your two small circles with that line segment, create that bisector going down the middle. Then you get the larger one using the larger radius. I doubled it, right, by 200. So scale factor multiplied by 2, right? Then it's the same radiuses for those circles but larger. Okay? Hence my isosceles triangle. Okay? Next one. Given this line segment of AB, construct a right triangle. Oh man, you want to make my life hard. Okay. Here you go. This is my original line segment. Let's create my circle here. Let's see, a little bit better. Okay. No fill. No. Let's scale this a little bit. Yeah, looks good, right? Looks good. Okay. So this should be its radius, right? Of so this becomes its radius. Okay. Then from here, I construct another radius. Okay. Because, right, it could go from the center to the left, or it can go center up. Okay. Again, sorry, it's not perfectly drawn to scale. Alright. There you go. That should be its radius, such that this is 1/4. Okay. Good. And what I can do here is that this makes. Okay, I should not move it. Grab this. Right. Okay. That's this circle. That's here. Grab one more on the bottom. Alright, so from here, okay, do you see it's two lines here? Okay. Okay, so let me move this up. I'll make the line that's going up and down this radius of this circle. So I'm going to make this red. So I'm going to make this line that's going down the radius of that red circle. Okay. So far I have the blue circle, which is that radius to the right. Then I have that red circle, which comes from the radius originally going up and down as the red now. Okay. So from here I can draw, I think I'm going to use one more, right? Oh, sorry. So here I can connect these two down here as a line. So hold on, give me a second. Shape from here, this radius down. Do you see that? Because it's the same radius. Good. It doesn't extend all the way, but you can make it array if you want. Okay. This becomes array. Oop, can I not change this into array? Oh man. Insert shape, make this array. Okay, so I could make this an extended array this way. Or I can go the ray the other way. Go from here all the way up here. Okay. Then from there you construct from your rays. There you go. That would be your right triangle. Okay. Next, go. Create an explicit and recursive rule for the visual pattern. Again, this is review from first semester. So, I'm going to go over this fairly quick. If you need a more in-depth explanation, please go back to those prior videos and watch it in greater detail. Alright, so here, we have to ask ourselves, is this recursive or geometric? It has 5, then it goes 5, 6, 7, 8, 9, 10, then 15. So it goes up by 5. Okay, it's a common difference of add 5, so we call this an arithmetic sequence. This is the formula for the arithmetic sequence. The first term, you start with 1, 2, 3, 4, 5, 6. The 0 term, how do I get the 0 term? I go back, right? If I go forward, I add 5. To go back, you minus 5. That's how I got 1. Plugging this into the equation of y equals mx plus b, or the arithmetic sequence of mx plus b. Okay. It's y equals 5x plus 1. Okay, for those, if any real math teachers are watching this, I understand this is not the real arithmetic sequence formula. I just realize that in the continuous form, right, it looks like y equals to x plus b because that's an equation of a line. Because the arithmetic sequence is the discrete version of the continuous function of the arithmetic sequence. Okay, don't argue. I understand that's not the perfect way, but it's good. Okay, number 10. Find an explicit rule and recursive rule for the square in step n. Okay, it goes from 1, then goes 1, 2, 3, 4, 5, then oh wow, it doubles. Wow, it doubles really fast, right? Doubles to 5, then doubles to 25. That's a geometric sequence because of that common ratio of multiplying by 5. You have it right here. This is the first term equation for a geometric sequence, f1 times r to the power of x minus 1. If you look at the 0 term, I think the 0 term looks like this. Hold on. This would be the 0 term equation. 0, this would be, this goes away. And this would be the 0 term equation of the geometric sequence. Okay, what happens in the first one? That's 1, common ratio 5. There you go. Okay, nothing about it. 11, 12, and 13, I'm just going to give you the answers. Alright, if you want to look for a more in-depth explanation, please watch all the prior videos, because the main purpose of this video was to help you with the construction. Okay, explicit, 10x minus 9, the recursive, right? That's the prior term plus 10 because the common difference here is plus 10. And this is geometric, starting at the second term. So this is the second term equation, x minus 2. At the second term, it's 16. Common ratio is 12. So the explicit is f equals mx 16 times 1/2 to the power x minus 2. Recursive, prior term times 1/2. Explicit for this one looks like it is going up by -5 as the common ratio. The explicit here would be -5 because that is your first term times -5 to the power of x minus 1. -5 was the common ratio and -5 was the first term. This is the first term equation for the geometric sequence. Alright, so there you go. Okay? Alright. These are all your solutions for the 7.2 Ready, Set, Go homework solutions. I have a disclaimer about number 8, okay? This is not the... There's different ways of constructing this, but this is the easiest way. There's more sophisticated ways, right? But I just want to make sure that you can do this on the basic term of just constructing all your geometric shapes, given a compass, which is a circle, and a straight edge. There you go. Those are all your homework solutions.